finally, right after that, just name it. I'm gonna name mine New Asgard. And that should be it. Let's hit enter. Yeah, that's done. Let's do a little Docker network ls action real quick. There he is, New Asgard, Mac Vlan. So now we have to try it out, right? So let's put Thor and Mjolnir into that new network like we have here. First we'll have to stop them, and we can do that with one command. Just Thor and then Mjolnir, just like that. And then we'll deploy them inside that new network. And of course here with our network switch, we'll specify New Asgard. I'll do a backslash to make things pretty on a new line. And then there's one more thing we have to do. I know I keep saying new things. We're gonna have to specify and assign the IP address ourselves. I'll explain why here in a bit. We'll go ahead and just do --IP, and then the IP address we wanna use. Just make sure it's not being used in your network, and that's outside your DHCP range. I'll do 10.7.1.92, that'll name it Thor like before, and finally specify BusyBox as our image. That should be it. Hit enter. Good to go. And now Thor is connected to my network like a regular virtual machine. Well, actually, maybe. Let me show you. Let's jump into Thor real quick. Jumping into his shell, if I do IP address show, I can see he does indeed have that IP address. Bam. But let's see if we can ping anything in my network. Like let's say, let's ping my default gateway, which should be his as well. Nothing happening. This right here illustrates one of the downsides of Mac Vlan. It sounds all cool, like it's amazing, right? But remember, with Mac Vlans, each of your Docker containers are getting their own MAC address. Now, where that becomes an issue is your network may not be able to have multiple MAC addresses on one switch port. So really, when I drew this out, the cable, the connection, is sharing a port with the host. They're all connected to the same port, which will see multiple MAC addresses, and a lot of times, ports can't handle that. They might have port security, which says you can only have one or maybe two MAC addresses on one port, and that breaks things. You'll often see this called Promiscuous Mode. I think I'm gonna spell this right. And if you wanna try this, you'll need that enabled. So if you're like me, it probably didn't work right now, but we can enable it and it should work, fingers crossed. We'll first start with the host. We have to actually enable Promiscuous Mode on its network interface. One easy command, IP link set, and then we'll specify our network interface. Mine is ENP0S3, then promisc, that's how the cool kids say it, promiscuous on. That should do it. Let's jump back into Thor and see if that worked. Ping my default gateway, still nothing. That means we have to go up the chain and change it on each network device. Now you're seeing the pain here, right? It's like, oh my gosh, Mac Vlan sounded really cool until we hit this issue. There's a different way to do it coming up in the next network, but hold on. Let's try one more thing. In VirtualBox, we can also enable Promiscuous Mode. Let me jump into my virtual machine settings, go to Network, click on Advanced, and right here, Promiscuous Mode is in Deny Mode. Well, of course it's not gonna work. So let's enable that. Let's just do allow everything. It's a lab, who cares? Click OK, and now, fingers crossed, give it a second. Okay, Chuck from the future here. I did have to reboot my host and then do that command once more, IP set link whatever. And now, fingers crossed, it totally works, connected directly to my network. So the Mac Vlan literally has all the benefits of a bridge network, except it's directly connected to your home network. Isn't that crazy? And when I say all the benefits, I really do mean it. So like, let's deploy, what was the other dude? What's the other dude in our network? Oh, Mjolnir. Let's deploy him. If I jump into him real quick, watch this. I can ping Thor. We still have that cool container DNS resolution thing. And what this also means is if I deploy a web server in a Mac Vlan, I don't have to expose any ports. It's on its own IP address. Let's try it out. We'll deploy Jane Foster as an Nginx web server, and we'll put her on, make sure this IP address is available. Yes, 96. And now, if we just go out to, this is so cool, 10.7.1.96, it just stinking works. That's my preferred Docker way to do things. It's awesome. Now again, as I mentioned, the Mac Vlan has a downside. Actually, two of them. That whole MAC address thing, having to have Promiscuous Mode, which you may have no control over, and something we haven't mentioned, and that's the IP address thing, no DHCP. You would expect that if you connect your device directly to your home network, it'll get an IP address from your router, or whatever's offering DHCP. No. In fact, it's even worse. If you don't specify an IP address when you deploy your container, Docker will choose one for you. Docker will use its own DHCP and assign like .2 or .3 or .4. You know, the way it does a normal bridge network, which could create a little bit of a conflict.
Yeah, a little bit of conflict.
The galaxy.
Thank you. Ready, guys?
A little
One,
bit alta.
2, 3. Galaxy. That's the gal I see. The galaxy. And I got a hacker.
Oh,
I need a hacker to be a spaceman. To the edge of space, man. Hack the galaxy.dev, see? The competition is heavy. What the FAQ?
create a little bit of a conflict because you got 2 DHCP servers in your network. So in that scenario, dude, just specify your IP address with every container. Or you can do it like Christian does.
So I do it this way. I specify the IP address range of the IP addresses the Docker host should assign to the containers, and I now limit this to just one IP address, not used by any other device within that network. This is really dumb, let's be honest.
And yes, I agree with Christian. It is pretty stupid that Docker does that. Why would I want that with the Mac Vlan network Docker? Now we'll talk about how we can solve the problems with Mac Vlan with the next network type, but the Mac Vlan, it has 2 modes. Didn't see that coming, did you? The mode we're looking at now is bridge mode. It acts just like a bridge network, except it connects to your network, which is, again, amazing. But there's another mode, and this one, it's gonna make the network geeks cry a little bit. With joy. Tears of joy. It has an 802.1q mode. With this mode, and if you're a networking geek, you already know where it's going. Not only can you connect your containers directly to your network, but you can also specify, this is so crazy, a sub-interface. So for example, eth0.20, eth0.30, which will have Docker actually create sub-interfaces auto-magically, and it will send these individual networks, these VLANs, over the link like it's a trunk. Which if I lost you here, then you probably don't care about networking as much as I do and others do. So think router on a stick with Docker containers on a host. And I'll show you what it looks like real quick. So let's assume 20 is VLAN 20 and 30 is VLAN 30. And here's their IP addresses. It's a completely different network. And let's create it real quick. First, I will delete my existing Mac Vlan. I'll first stop Thor and Mjolnir. I'll remove the network with sudo docker network rm and then new Asgard, the name of the network. Oh wait, I forgot he had one more endpoint in there. He had Jane Foster. Sorry, Jane Foster, I forgot about you. Okay, now it's removed. Now let's recreate that Mac Vlan with a few pretty big differences. Here we got a new subnet, a new gateway, and a new sub-interface, which it'll be the host interface, same as before, so it'll be parent equals en, was it pp? Yeah, 0s3. And then to create that sub-interface, it'll be .20, which that sub-interface currently does not exist, but Docker will auto-create it when it sees you doing this. And then we'll name it, I'll just go Mac Vlan 20. Oh, I totally forgot to do create network. Okay, network. There we go. Oh, too many ticks on my O. There we go. Why is it not working? Oh, totally forgot to do Docker network create. Okay, gotta get that right. There we go. So now I have to do IP address show. New sub interface. Now, of course, in that scenario, you would need to have trunking set up, which I'm not gonna cover. That's out of scope of this. That's pretty stinking cool. Now I'm gonna delete that because I don't need it right now. And let's talk about our next network. Now this one solves the big problem with Mac VLANs, that stinking promiscuous stuff. And it's actually, I think, probably my favorite over Mac VLAN because it has 2 very funky modes. Well, one of them's funky. The other mode is fine. This is called IP VLAN. It has 2 modes, L2 and L3. We're gonna focus on L2 because it's pretty much the stinking same as Mac VLAN with one very awesome difference. And it solves our problem. So whereas Thor and Mjolnir in a Mac VLAN, they are assigned their own MAC address, which sounds cool in theory, but it really isn't because it messes with our switches and the promiscuous stuff. You got it, right? With IP VLANs, nope, they don't do that. Instead, they keep all the awesomeness of connecting it directly to your network and getting a real IP address, but they allow the host to share its MAC address with the containers. So Thor and Mjolnir, its MAC address will match exactly to the host, but they'll still have IP addresses on our network. This seems to resolve all issues, and in most cases will, as long as your switch, your router, or security stuff are okay with there being one MAC address with like 20 IP addresses. But for the most part, it should be fine. So let's actually create that right now to solve our promiscuous issues. To create that network, same story as before. Docker network create. We'll do a -d for our driver we're gonna use, and it will be IP VLAN. Now to do IP VLAN mode L2, you don't have to think about it. That's the default mode. So leave it as is. And at this point, it's pretty much the same as the Mac VLAN. You'll specify subnet, gateway, parent interface. We'll name it. Again, new Asgard will work. And that's it. And when we add our containers, specifying to use the new Asgard network and assigning our IP address because it will still have that annoying IP address issue. Didn't get rid of that. We'll launch Thor. Let's jump into Thor real quick. See if we can ping our gateway. Golden. Let's ping the internet. And then let me show you how they have the same MAC address. Let me exit, I'll do IP address show on the host. Notice the MAC address of EMP0S3 is, where'd it go? Right here, ending in 33.8 or AD. If I bring up the command prompt on my computer and ping 10.7.1.92, it'll take a second to resolve it. It's trying to get through a bunch of stuff. There it goes, had me nervous for a second. Yeah, it's still working. If I check my ARP table, well, look at that. The MAC address I see for 10.7.1.92 is the same as my Ubuntu host. Okay, cool. IP VLAN L2. Nothing too crazy, pretty much same as Mac Vlan, except just a little bit better in a lot of situations. Now time for L3, and this one's probably my favorite out of all of them because of how crazy it is. The internet was begging for this, and Docker finally made it happen. And it's pretty much a love letter to networking nerds, so you're welcome. Ipvlan L3 is all about layer 3. And when I say layer 3, I mean IP addresses, routing, routes. That's all we're talking about here. So far actually, with our bridge, Mac Vlan, Ipvlan, it's all been very layer 2 focused. Dealing with MAC addresses, ARP, responses, and requests. Everything's very layer 2 and switch-like. But with L3, nope. No more switching. No more switching, no more ARP. We're all layer 3, IP addresses. So with Ipvlan L3, we're not connecting our containers to our network like it's a switch. We're connecting it to our host like the host is a router. What? I'll explain, watch this. Let me give you an example. So here we're gonna create 2 new networks out of thin air, okay? We got new Asgard up here with the network 192.168.94.0/24. And then we'll do, I don't know, like Earth. I'm getting lazy with my examples. Earth with 192.168.95.0. Now what I want to point out right now is that these networks brand new. They don't exist on my network at all. My home network has no idea how to reach these. Totally brand new. When we deploy these networks and throw these containers in there, these containers' connection to the outside world is completely layer 3. They connect to the host like it's a router. These are layer 3 connections. And what that means for networking people is that there's no broadcast traffic anymore. No broadcast traffic, which you know can be a very, very good thing. Because if you have a pretty complex layer 2 network, you've got bridging loops you have to worry about, all those BPDUs, BPDUs spinning around. And for a bit, it's been best practice to remove a bunch of layer 2 and focus on layer 3 connections to your top of rack switches, right? I know I'm going real deep on networking, but that's what this is for. So because it's layer 3, no broadcast, it's not responding to ARP request, which again is very cool for network nerds. But the problem we have here is that right now these containers really can't talk to anyone outside of their own network. Like for example, Thor cannot go to the internet. Thor can't talk to me, which is really sad. I can't talk to Thor. I cannot reach containers in that network at all. Exposed ports doesn't happen. That's not even a thing because we're dealing with layer 3 and we're dealing with routing. And right now, my network and all my hosts in my network have no idea how to reach 192.168.94.0. That's an like they don't have a route for it. It's not in their routing table. So that might sound kind of stupid. It's like, why would you deploy this if they can't reach anything? Well, it's because you get more control. And control is the name of the game here. You can do some crazy isolation with your containers, and you can restrict and isolate them via layer 3, via networks. So again, right now, no one can reach them, but I can control who reaches them. All I have to do is in my network, my home network, I just have to tell my router, hey, if you want to reach 192.168.94.0, I know where you should go. I want you to go to the host 10.7.1.232, the Ubuntu host. He'll know how to get there. Because remember, he's functioning as the router. So I'm just telling my home network, hey, this network is kind of a weird one. If you want to talk to these guys, they're over there. Talk to that dude. And that's really how networks work. It's a static route. It's so cool. Let's deploy it real quick. You can deploy this in your own home network right now. You just have to have access to your router to be able to do this. So real quick, I'm going to delete my previous Ipvlan network because you can't have more than one network linked or assigned to a network interface. And I only have one network interface on my machine here. So I will stop Thor. No one can stop Thor but me. Then I will remove new Asgard. And now let's create an Ipvlan L3 network. Same story as before. I've been saying that a lot. Docker network create. Our type will still be Ipvlan when we do -d. And then we'll specify our subnet, which is going to be a brand new network we're creating right now, 94.0/24. And then the big thing we don't do here is we don't specify a gateway. Because with a Ipvlan L3 network, the gateway is going to be the parent interface we tie it to. We don't have to specify that. It'll just be that way. That's pretty cool. But we will have one more new thing. So let's do a -o parent. We'll specify the parent interface, which again was, for me, ENP0S3. Then we have one more -o. This is how you specify additional options. We'll do Ipvlan_mode equals L3. And that puts it in the L3 mode, as it, you might have guessed. And you might think, oh, hey, that's it. No. We're gonna go ahead and specify our other network. We'll do subnet.